looking at expanding terms. So let us look on example 1. So in our first example, what we have here is, in this example, what we're noticing is that negative 3 will be used to multiply by 2x plus 4. So basically, negative 3 will be multiplied to 2x, and then it's going to be used to multiply to 4. So let us deal with it. So negative 3x, we're going to use that to multiply by 2x. And then this same negative 3x will be used to multiply by 4. After this, we want to simplify what we have. So negative 3x times 2x is going to give us negative 6x to the second power. Remember that when you multiply the same letter, you add their powers. So this is actually x to the 1, x to the 1, which is going to give us x to the second power. For this, negative 3x times 4 will give us negative 12x. So in my second example, so let us say we have this, we want to expand, get rid of the parentheses, and then we simplify. So in terms of what we have to do, this 6 here will be used to multiply by the 2y, then the 6 will be used to multiply by negative 4. Then we're going to use negative 2 to multiply by 3x, and then this same negative 2 will multiply by 1. So in our first instance here, we're having 6 times 2y. Remember that this is a positive 6, so it's positive 6 times negative 4. Here, what we have is negative 2 times 3y, and then negative 2 times 1. When we put this together, we're going to have 6, we're going to have 12y minus 24. Negative 2 times 3y will give us negative 6y. Negative 2 times 1 is actually negative 2. So basically, we have this, but we're noticing that we have like terms. So if we take a quick look here, we're noticing that this is, here is that our 12y and negative 6y are alike. So if we should put them together, remember, 12y minus 6y will give us 6y. Negative 24 minus 2 will give us minus 26. And that's the answer for that part. So basically, we get rid of the parentheses, and then we simplify. Let's take a look at another example. We're actually multiplying 2 binomials in this case, right? So we're multiplying 2 binomials. So here it is. The idea is that every element from the first parentheses will be used to multiply by every element from the second parentheses. A systematic way of doing this is to take out the elements from the first one. So 4x will multiply by 2x minus 3, and then plus 1 will multiply by 2x minus 3. At this stage, then we're going to just execute our regular distribution. So 4x will go with the 2x, then 4x will go with the negative 3, then 1 will go with the 2x, and then 1 will go with the negative 3. So let us finalize this. Basically, 4x times 2x. Remember, this is positive 4x times negative 3. So I just dealt with this. Let us deal with the other bracket over here. So 1 times 2x, and then plus 1 times negative 3. When we multiply 4x times 2x, we're going to have 8x raised to the second. 4x times negative 3 will give us negative 12x. 1 times 2x is 2x. 1 times negative 3 is negative 3. If we're going to try to finalize this, as you could see, we actually have like terms here. So then we could put together those in the middle because negative 12x plus 2x is negative 10x, and then negative 3 is by itself. So this is our final response. Is to figure out what does it mean to square, right? When something is squared, then that thing is multiplied by itself. So what we actually have is 5p minus 1, and that is going to be multiplied by 5p minus 1 again. So after doing that, then we're right back at our third example. So I'm going to take off 5p, and I'm going to multiply that by 5p minus 1, which is this parentheses. Then I'm going to have negative 1, which is this, and I'm going to use that to multiply by 5p minus 1. Times 5p times 5p, I'm right here. Then 5p again times negative 1. And then negative 1 times 5p. And lastly, negative 1 times negative 1. After doing that, we want to simplify this. So let us do that. When 5p is multiplied by 5p, we're going to get 25p, but raised to the second power. As you could see, p times p gives us p to the second power. 5p times negative 1, it does gives us negative 5p. Negative 1 times 5p gives us negative 5p. And negative 1 times negative 1 is positive 1. After doing that, we're noticing that we do have a like term there. We have p's. So let's put it together. We'll have 25p to the second because there is no other term to be added or subtracted to this p to the second. But these will become negative 10p, and there's a plus 1 after. So basically, there it is. All right?